Okay, we have another lesson on ways to display data. And so in this section, we're going to look at how to understand and explain line graphs. We'll also look at scatter plots for two variables. We'll look at the relationship between a pair of variables using a scatter plot. Then we'll look at something called a trend line, which is also called a line of best fit. You might remember that from your algebra class. We'll also look at positive association, negative association, and no association. And then we'll look at how to choose a data display. Okay, with line graphs, they typically show trends in a variable over time. So time is usually marked on your horizontal axis, with the variable being considered marked on the vertical axis. Consecutive data points are connected by line segments. So here's an example of a line graph. Our time is the horizontal axis, like we mentioned before. This graph is showing a person's weight over 10 years. And so our time is the age, and then the weight in pounds. This is the first example of a depiction of continuous data. All the other data that we looked at, so the graphs and things that we looked at last week, they examined what we call discrete data. Okay, so if we look at these two graphs here, these are both examples of line graphs. Both of them are showing the number of graduates of a community college. But they look like very, very different graphs, and they do not display the same psychological message. Can you see why? Yeah, see how our vertical axis is more spread out here than what we had here. The graph on the right, we have a scale of 50, whereas on the graph you have a scale of 10. So even though when I look at 2004, it's at 140, and that is about that as well. Look at 2007, see how it's up at 210? Well, when you're going by 50s, 210 doesn't look like as much of a change as what we're seeing here. Okay. So it's really going to be important to make sure that you use a good scale whenever you're making the graphs, so that the presentation reveals what you want it to reveal and isn't misleading. Sometimes a relationship between variables cannot be easily depicted by even a broken line, so a scatter plot may be used. And one more thing about this back here, I think we talked about this last week. When you're going to jump up to like 130 or 100 on the graph, you can make a break in your graph to show that this doesn't start at 0, because otherwise it might make people think you have a scale of 130 here or a scale of 100 here. Okay, when your scale, if you look at the next two numbers, is actually 50, or over here it's actually 10 on the left. Okay, so you can make that break in your graph. I think we talked about that last week, but I wanted to make sure. Okay, back to scatter plots. Okay, here's an example of a scatter plot. This scatter plot shows the relation between the number of hours studied and the quiz score. The highest score is 10 and the lowest score is 1. Okay, so once again, time is your horizontal axis. This time it's the number of hours studied, and then your quiz score. So as you can see here, the longer that someone studied for the test, generally the better they did on the test. Okay. Now, when you have a scatter plot, you're plotting like this person here studied for 0 hours and they made a 1. This person studied for 1 hour and they made a 1. This person studied for 2 hours and they made a 2, and so on. Okay, so that data is representing the number of hours scored and the actual, the number of hours studied and the actual score with each point there. Okay. In this next graph, this is taking our scatter plot and drawing what we call a trend line on the scatter plot. So a trend line is a line that closely fits the data, and it can be used to describe it. So for example, the equation for this trend line is y equals x minus a half. Okay. So if you know the equation for the trend line, then you could predict that someone who studied 7 hours, you could predict what their score would be by just taking the 7 and substituting it in for x. So y, which is the quiz score, would be equal to 7 minus a half, which would be 6.5. Okay. Now, we spent some time in part 1 going over how to write the equation of a line, but I know some of you are taking this out of order. So when we have a question about the trend line, I will give you the equation. You will not have to come up with it, but just know once you have the equation how to find and make a prediction. Okay, so here we're trying to predict, let's say you were trying to predict what someone would make that studied for 8 hours. Then 8 is your x, it's your horizontal axis. You would take 8 and plug it in for x and work it out to get your answer for y, which is your quiz score. Okay, you may have noticed on the last example that all of your points were kind of going up. Okay, we ended up having a positive slope on that trend line, okay, to represent the fact that when it slopes up, there's a positive association between the data on the horizontal axis and the data on the vertical axis. An increase in the value of the variable on the horizontal axis would predict an increase in the value of the variable on the vertical axis. So when all of your points are going up, like a positive slope, then you say that the scatter plot has a positive association. When all of your points are clustered to where they go down, and it looks like your trend line would be going down, then your trend line will now have a negative slope, and we say that scatter plot has a negative association. That just means that an increase in the value of the variable on the horizontal axis will predict a decrease in the value on the vertical axis. Okay. Then you could have a scatter plot that has what we call no association. So if I look at these points here on this graph, you can't really tell where to draw a trend line. You can't tell if it would go up or down. You just have random points scattered here, and they don't really seem to have any kind of association. They're not all falling up or all falling down. So here we say no prediction of one variable can be made based on the value of the other. So there's no association there. We can also use multiple line graphs together to demonstrate different sets of data where comparisons may be made. So here's an example. We've got a graph that shows the crowdedness of housing from 1940 to 2000. One line showing crowded with more than one person per room, and the other is showing severely crowded with more than 1.5 people per room. And so sometimes it's nice to have both of those graphs on the same graph so that you can see a little bit more about that data. Okay, so we've talked about lots of different ways that you can display data. So let's look at how to choose which type of graph to display. Choosing the right display is not always easy, and there may be more than one appropriate choice. Okay. But here's a general rundown of each type and when you should use it. Okay, a pictograph, we talked about that last week. That's going to be used to show data with pictures or symbols. A dot plot is used most often to show frequencies. A stem and leaf plot is used to show each value in a data set and to group values into intervals. The bar graph we talked about last week is used to compare numbers of data items in grouped categories. And then the histogram is used to compare numbers of data items typically grouped in numerical intervals. And here, order matters in the data depicted. And then the circle graph is used to show the division of a whole into parts. The percentage bar is also used to show the division of a whole into parts. And then the types of graphs we talked about this week, starting with the line graph, that one's used to show how data values change over time. It's normally used for continuous data. And then a scatter plot is used to show the relationship between two variables. Okay, that is it for 10.3.